Hi math students, welcome back. We are on lesson 7, which is part of project 2. And this lesson has 4 questions, or this project. Officer Franklin is on traffic duty. His motorcycle is parked alongside the freeway and he is using his radar gun to check the speed of cars. The speed limit on the stretch of highway or freeway is 75 miles an hour, and a sports car races by Officer Franklin, causing him to lose his grip on the radar gun. When he picks it back up, he clocks the car at 93 miles per hour as it passes a bridge 1/2 mile ahead of him. Okay, so we are going to try and put this into a linear equation. And let's scroll here, and we want to consider the slope-intercept form of the equation representing the line that the sports car's distance is from the officer's location over time. Okay, so basically what we're looking at here, and I want to have this, is, all right. At this point here, okay, the distance, okay, the car isn't right next to the officer. The car is already a certain distance away, and the car is going to continue to move further and further away, so further and further up this line, at a constant speed, or so we think, and that speed is 93 miles per hour. Okay, so this is time and this is distance, so our slope is going to be 93 miles an hour. So that kind of helps us answer this first question. If we are going to do slope-intercept form, which is y equals mx plus b, all right, the coefficient of x, which means the number or variable in front of x, is our slope, okay? So that is always going to be slope, that coefficient of x. And in this case, it's going to be 93 miles an hour because that is the rate at which the car is moving away from the officer. Okay? And I'm just going to kind of keep a lot of the same stuff here. And we're going to scroll down and answer the second question. Okay, so we've got the same graph, but in this instance, it's asking us what is the constant term and what does it represent? So the constant term, if we're looking at y equals mx plus b, is b, okay? And remember, b represents that y-intercept, okay? Meaning that that car is never going to be any closer, especially since we're dealing in time, so we can't go to negative time here. So that car is never going to get any closer than 1/2 mile away from that officer. It's going to continue to get further and further away at 93 miles an hour. So our B value is where that line crosses our y-axis, or 0.5 miles. So that is our y-intercept, and it crosses at 0.5. So we have y equals 93x plus 0.5. Okay, so that means it's 0.5 miles away plus 93 miles for every additional hour. Okay. We'll scroll down. So we basically answered this one. They want to know what is the slope-intercept form of the equation of the line that represents the sports car's distance from Officer Franklin's location y after x hours. Well, that's exactly what we just wrote down here. And we could even type that in. Y equals 93x plus 0.5. Okay, and I think actually when you do this, be really careful. I don't think you want to put in spaces. It can be very picky on how it accepts answers. So no spaces, and just make it y equals 93x plus 0.5. Okay, and the last question here is an essay question. And they say Officer Franklin's radar gun stops working in the middle of the day. As a vehicle passes by him, he starts his stopwatch. As the vehicle passes the bridge 1/2 mile away, he records the time as 30 seconds or 1/20th of an hour. So how could he use this information to determine the speed of the car and its location? So this is a little bit different, but it's not, we're going to work the problem the same way. So in this scenario, okay, the officer starts the stopwatch at time equals 0 and distance equals 0, okay? So our y-intercept is going to be 0, all right? Because the officer is starting the stopwatch right as soon as the car passes by him. So that is time 0, distance 0, okay? And then at time equal 30 seconds or 1/120th of an hour, okay, the car is 0.5 miles away. Because remember, the y-axis here is distance and the x-axis is time, okay? So now we have another point here at 1/120 and 0.5, okay? So now that I have 2 points, I can calculate the slope of the line, which will be the speed, and I can determine whether or not the car is speeding. So let's do that. I'm going to have m equals y2 minus y1 over x2 minus x1 equals 0.5 minus 0, okay, my y2 and my y1, over 1/120 minus 0, so x2 and x1. All right, so the zeros are just going to go away here, and I'm going to have 0.5 over 1/120. So when I've got a fraction in the denominator, I can flip it over. I can basically multiply both sides by the reciprocal, and it'll get rid of that fraction in the denominator. So I'm going to end up here with m equals 0.5 times 120 over 1, okay? And 0.5 times 120 is 60, okay? And since there's the 1 in the denominator, 60 over 1 is just 60. So 60 miles per hour is not speeding when the speed limit was 75 miles an hour that we learned initially. So that is what you need to write out for this one. Just show me how you came up with the slope and that you realize it's not speeding. So that's all for lesson 7. Thank you.